Hey class, team members are Arturo Escamilla, Hector Garcia, Fernando Vasquez, and myself, Christopher Guzman. We're going to be talking about data structures. Overview. A data structure is a group of primitive data elements organized for some type of common processing and is defined and manipulated in software. Computer hardware can't manipulate data structures directly. It must deal with them in terms of their primitive components, such as integers, floating point numbers, single characters, and so on. Software must translate operations on data structures into equivalent machine instructions that operate on each primitive data element. Certain data structures are useful in a wide variety of situations and are used commonly, such as character strings or arrays, records, and files. System software often provides services to manipulate these commonly used data structures. For example, an OS normally provides services for reading from and writing to files. Other data structures are less commonly supported by system software. Examples include numeric arrays, indexed files, and complex database structures. Indexed files are supported in some, but not all OSs. Numeric arrays are supported in most programming languages, but not in most OSs. Database structures are normally supported by a database management system. Data structures have an important role in system software development. For example, OSs commonly use linked lists to keep track of memory blocks allocated to programs and disk blocks allocated to files and directories. Indexes are widely used in database management systems to speed search and retrieval operations. Pointers and addresses. Almost all data structures make extensive use of pointers and addresses. A pointer is a data element containing the addresses of another data element. An address is the location of a data element in a storage device. Addresses vary in content and representation depending on the storage device being addressed. Secondary storage devices are normally organized as a sequence of data blocks. A block is a group of bytes read or written as a unit. For example, disk drives usually read and write data in 512 byte blocks. For block-oriented storage devices, an address can be represented as an integer containing the block's sequential position. Integers can also be used to represent the addresses of a single byte in a block. Arrays and lists. Many types of data can be grouped into lists. A list is a set of related data values. An array is an ordered list in which each element can be referenced by an index to its position. In a high-level programming language, array elements are normally referenced by the array name and the index value. A linked list is the data structure that uses pointers so that list elements can be scattered among non-sequential storage locations. Each list element occupies two storage locations. The first holds the list element's data value, and the second holds the address of the next list element as a pointer. Arrays and lists continued. More storage locations are required for a linked list than for an array with equivalent content because both data and pointers must be stored. Linked lists are easier to expand or shrink than arrays are. Each element of a doubly linked list has two pointers, one pointing to the next element in the list and one pointing to the previous element in the list. The main advantage of doubly linked lists is that they can be traversed in either direction with equal efficiency. The disadvantages are that more pointers must be updated each time an element is inserted into or deleted from the list, and more storage locations are required to hold the extra pointers. Records and files. A record is a data structure composed of other data structures or primitive data elements. Records are commonly used as a unit of input and output to and from files or databases. A sequence of records on secondary storage is called a file. A sequence of records stored in main memory is normally called a table, although its structure is essentially the same as a file. Files can be organized in many different ways, the most common being sequential and indexed. Sequential files suffer the same problems as contiguous arrays when records are being inserted and deleted. One method of solving this problem is to use linked list. Another method of organizing files uses an index, an array of pointers to records. The pointers can be ordered in any sequence you need. The advantage of using an index lies in the efficiency of record insertion, deletion, and retrieval. Classes and objects. A class is a data structure containing both traditional static data elements and programs that manipulate the data. The programs in a class are called methods. A class combines related data items in much the same way a record does, but it extends the record to include methods for manipulating data items. An object is one instance or variable of a class. Each object can be stored in a storage device, and each object's data elements occupy a separate part of the storage device. Viewed as just another data structure, an object differs from a record. And that's all this uh, topic has to deal with. Thank you.